So x plus y equals 5 and x minus y equals 1. And the second thing you need to do is to build one equation up here and the other equation here. Here's what simultaneous equations are. Simultaneous equations are combining the two equations. Right? Push them in. Just push them in. Okay, it is physically combining the two, well, it's physically now, we've got to do some algebra. It's physically combining the two equations so that something will cancel, okay? Same shape, different colour, cancel. And instead of having two equations with two letters, we end up with one equation with one letter. Okay? That's the first step. Okay, so hopefully you've done that. And now we need to write it as soon as I find my pen. So what we did is we combined or added, so we added them together in the middle. So you need to say what you are doing. I got equation 1 and I added, or equation 1 and equation 2 and I added the two together. Colon, to say that's what you're doing, and now here's the algebra of that. So the result of pushing those together is we've got 2x's here and 6 here. Now because we need to solve, we want to know what 1x is. So I'm going to divide into two groups. And I end up with x equals 3. Now, I want you to rebuild the two original equations, please. Okay, now, we know half the answer. We know what x is. Obviously, we want to know what y is. We need to get whatever that answer is and put it into one of the equations. Now, it doesn't matter which one, okay, but let's avoid the one with the minuses because we know minuses tend to cause problems. So I'm going to get my answer. You can do something different, so long as you're recording you're working. I'm getting my answer and substituting it into equation 1, which means I'm replacing x with 3. Right, my evidence so far tells me that x equals 3, so I'm substituting 3 for x. Okay? And so I end up with, what I've just done is I've replaced x with 3, and this is what I've got now. Right, it's up in section 1 there. And of course I want to solve for y, so I'm going to subtract 3 from each side. And I'm ending up with y equals 2. Okay, I think I have the answer. I think the answer is the 0.32. However, we have the ability to check, and we're going to check using the equation we didn't use last. If you use the same thing, like if you, I don't know, Google some information and then you want to check it, you don't go to the same site, you go to a different site. That's what you thought we know this, do we? Okay, so to check it, we want to use something different to what we just used. So we're going to use equation 2, which means that I know that x equals 3, or I think I know x equals 3, y equals 2, so negative y equals negative 2. Right, so there it is, I've just substituted into equation 2. So I replaced x with 3, I replaced y with 2. And is that true? Yes, it is. Once we get something sensible like 3 equals 3 or 5 equals 5, yes, everything's right. If we get something silly like 3 equals 2, we need to go back and find out what went wrong. Okay, so now we can say, therefore, intersection point. And question 1 is done.
That was really easy.
It was easy. No,
Just,
not
it looks really
it's long. Tim?
You have to do the check.
Yes. Okay, now, don't do this. If we combine them, does anything cancel? No. Okay, so this question, so the first question was sort of the easiest possible one, where the minimal amount of work was required from you. Okay, so adding them together doesn't work. Instead of adding, we need to really subtract. start with equation 1 because it's bigger. I've picked 1 take 2 rather than 2 take 1 because that one's bigger. Now there's a couple of ways we can do this. I'll show you what we're going to do. We're going to actually take this away from this one. So let's push this one down. So we're starting with equation 1. So let's put that in the space. Right. And we're taking this away from that. Okay? So I can take an x away, I can take a y away, I can take a 2 away. And that's what I'm left with. Okay? What I did is there was 2 x's in equation 1. I took away the x from equation 2, which leaves me with an x. Y take y, gone. 3 take 2 is 1. And we've achieved our goal, which is one equation with one letter. However, from there, it's the same as what we did before. We're going to put that answer into one of the equations. It doesn't matter which one. I'm a little bit OCD, so I'm going to go into equation 1. So I'm going to rebuild equation 1.
What have I done?
Okay, so I've got an answer. If you didn't follow the step I just did, just hang in there for the minute. But what I've done, so you might just need to take this on trust for the moment. What I've done is I've rebuilt equation 1. And I think this is the answer, so I'm going to substitute that answer into equation 1. So I'm going to replace x with 1, and of course the other x also with a 1. So x is being replaced with 1, so this equation becomes that. And then of course I'm going to subtract 2 from each side. Yep. My aim is always to get, not always, mostly to get a letter by itself, so I'm subtracting 2 from each side. And I end up with y equals 1. Did you still have a question, Hannah? We're doing this example a different way. Then we need to check, not using the same site we just used a minute ago, we're going to a different site, different equation, which means, so I could build it if I want, I can replace x with 1 and y with 1, right, but you've got to actually write it, x with 1, y with 1. Is that a true statement? Yes, it is. So now I'm confident to say the intersection int point, I would write the full word in a test, int point is 1, 1. We're doing question 2 again, differently. So write it, label it, and build it. Okay, here's what I'm going to show you. I'm going to get equation 2 and I'm going to multiply it by -1. I'm going to get equation 2 and I'm going to multiply it by -1. What does that do? It changes everything to the opposite. Okay, multiplying by -1, so x gets multiplied by -1, so there's a negative in front of it. Y gets multiplied by -1, so it's turned from a positive to a negative. Multiplying by -1 changes the sign. So that turns into that.
And then you can just push them together.
Okay, so what I've done is I've changed everything to the opposite sign in equation 2. Haven't changed it because I've done the same thing to each side. I've just made it look different, but it's still the same equation. Okay, now when I combine the two, so if I get equation 1 and add it to the changed version of equation 2, there we go, I put them together. It's literally just physically pushing them together, combining them. Okay, same shape, opposite sign, cancel. Same shape, opposite sign, cancel. Same shape, opposite sign, cancel. And there's our x equals 1. And from there it's the same. I would substitute that into equation 1. I get y equals 1. Okay, I'm not going to do the rest. Same from here. So there's another aspect. This is harder again. I'm showing you the range of things that you will have to do with the elimination technique. So copy the questions, label them, and build them. Okay, if I push them together, does anything go away? If I subtract this from this, so if I subtract an x, 2 y's and a 1, will that leave me with one equation with one letter? No. Okay. So if you look back at the notes we wrote, well, has anyone got a suggestion before I tell you? Yep. If I change the bottom, so the next suggestion was multiply the bottom by -1, which works for the last question.
But it's not going to work for this one.
It's still not going to work for this one. Okay, so good thinking, but it doesn't achieve the goal.
How is it?
Okay, so instead we need to get, so times it by 2 or -2 is the answer. Okay, because if you look back at the notes, what I said is for this system to work, shush please, for this system to work, the coefficients need to be the same for one of the letters. Okay, in both equations. So there's a 2x here and 1x there. They both need to be 2x. Or these both need to be 3y or 6y or something. Okay, so let's double. So the easiest thing to do is to get equation 2 and double it. Okay, let's do that to start with. Let's get equation 2 and double it. Equation 2, I've doubled it. Now that we have the coefficients the same, now if we add them, of course, they'll just combine. But if we subtract them, or if you need to change this to the negative version and add them, that's what we do. But have a look. I can take there are 2 x's in that equation. I can take them away. There are 3 y's in that equation. I can take them away. There are, okay, I can't take 5 away, but I can add the opposite. 2 take 5.
That's annoying.
It is a little bit
That
annoying.
is very annoying.
You're annoying.
Okay, so I couldn't physically take 5 away, but if we can't take something away, we can always add the opposite. Okay, so there's the answer once I've cancelled. Okay, let's have a look with the algebra. Okay, I don't want you to be using this or needing to use it in the HSC. This is to help you see what's happening, but you've got to be able to see what's happening with the algebra. Okay, what did I do? I got equation 2 and subtracted equation 1. So 2x, take 2x, x's went. 4y, take 3y, left me with 1y. 2, take 5, left me with -3. This is the substitution technique. To do the substitution technique, you need a y by itself or an x by itself. Okay, and this first question, they were very nice and they gave you the y by itself already. Substitution means replacing one thing with something else. So here it is, there's the y. Y is equal to this, so I can substitute. Right, I'll do it again. There's y, here's what y is equal to. So I can replace the y with what the y is equal to. Okay? And I'm looking for my pen. So here's what I just did. I got equation 2 and I substituted it into equation 1. So equation 2, it's not equation 1 into equation 2. I got equation 2 and I substituted it. That's the arrow into equation 1, writing and working. Okay? So that means here's equation 1. It started off with an x. I replaced the y with an x plus 1. And then there's an equal 5. There it is, x plus y equals 5. Okay? Now I'm going to simplify. 2 x's. Same shape goes together. Solving. Subtract 1 from each side. And then dividing into 2 teams gives me x equals 2.